Our reaction here is epoxidation. Epoxides are three-membered rings containing an oxygen. And here we'll just learn how we make epoxides. Much later on in Organic 2, we'll learn what epoxides are useful for. But like many other three-membered rings, epoxides are generally not very stable. So the easiest way to make epoxides, and most used method, is to use MCPBA. MCPBA, which stands for meta-chloro-per-benzoic acid, has the following structure. Again, this is the most common reagent that we use to make epoxides. And so in this reaction, the double bond in the ring is converted to the three-membered ring. This reaction has been known since the very early 1900s. And we'll look at its mechanism now. Its mechanism is just a single step, or what we refer to as a concerted mechanism. In other words, the entire reaction takes place in one step. So we don't need to draw out the aromatic ring with the chlorine here. It doesn't actually play a role in the reaction, so we'll just abbreviate it as R. But what we have is just a series of steps. The oxygen here within this, what we call a peroxy acid or a per acid. So this is a carboxylic acid that has an extra oxygen in it. It has some unusual reactivity because it's bonded to another oxygen. But with those four arrows, we can see our flow of electrons that takes us from our alkene to the epoxide, and then the meta-chloro-per-benzoic acid, which again has lost one of its oxygens, gets converted as a byproduct to meta-chloro-benzoic acid. And so we can just look at a couple of additional examples. But pretty straightforward what's going on here. And ultimately, the utility in the epoxidation reaction is not the epoxide itself, but the fact that epoxides, these three-membered rings containing oxygen, can very, very easily be converted into a number of other compounds. As we'll learn later on, the epoxide, the carbons of the epoxide are electrophilic. And so we'll see later on in the course that these epoxides, again, we can easily add nucleophiles to them, which will open up the three-membered ring, allow us to have added a nucleophile, and the oxygen will still be present as an alcohol. So very, very useful synthetically, but by themselves, the epoxides aren't all that interesting.